The final presentation of this session is by Don Mathews. Don is the Technical Manager and Chief Engineer for Pavement Recycling Systems Incorporated in Jurupa Valley, California. He has headed PRS research and development since 2003, focusing on the use of recycled products in pavement preservation, automated machine guidance, and intelligent construction technologies. He is a member of ARRA. Don, the floor is yours.
Today, you've heard a lot about cold recycle and hot recycling, and it all focuses around wrap. Well, I want to take it a little bit different and talk about best practices for wrap stockpile management. So you have all these piles of wrap. How do you use them effectively? One of the things is, let's just talk about what we know. Asphalt has always been recyclable. In fact, it's second recycled material just behind water. So we have used it for years, and typically it's been hot mix applications, and it's a valuable material in hot mix asphalt. But sometimes it's limited on how much you can use in it, and sometimes it's not even cost effective to do so. So in a lot of places, we're taking in more material off the roadways than we're sending out. So we're building up stockpiles of wrap. But it's such a valuable material. We really don't want to squander virgin aggregates. You can see this pit in an urban area near homes, not in my backyard, literally almost in this case. But wrap outperforms native aggregates in a lot of cases. Right now, in a lot of areas, aggregates are limited. And so some of the best aggregate was used in the pavement. So it's a valuable material. Wrap has a neutral charge. It works well with emulsions and asphalt. It's very effective binder, very effective with a lot of different binders. It's cost effective, and obviously it's environmentally smart. So when we talk about wrap uses in pavement preservations, we talk about mixes, and we talked a lot about that today. Hot mix asphalt, using wrap in that. Cold central plant recycling, Steve just talked about that. But also you can use it as aggregate replacements in chip seals, slurry seals, microsurfacing, cape seals. I've done a lot of talking about that with the NPPC over the years about how you can use your wrap in pavement preservation, and there's an actual growing use in that. So let's talk about really what's the value in the wrap. Obviously the aggregate, all the rock, the sand that's in there, but it's also the residual asphalt binder. And that's really the most governing factor, is the binder that's in the wrap. So when we look at aggregate variations, we look at gradations of the material, but also gradations of the wrap versus gradations of the parent rock, or the extracted rock that's bound up in the asphalt. We look at the quality of the parent rock. Is it hard? Is it durable? Is it reactive? Is it absorptive? In many cases, the asphalt was used as kind of to prevent absorption. You have to use more asphalt in some less quality aggregate areas. And so when we're looking at wrap, we got to think about, are we looking at single stones to conglomerations? And if you look at the picture, that left is almost just a pure stone the asphalt's been wore off. And then as we get more and more to the very right side of it, it's a conglomeration. Well, that's why it's so important to think about that residual asphalt binder. And when we're looking at most areas, the wrap is likely to remain pretty consistent. The exceptions are, did somebody patch the roadway? Did they put in some solvent-bearing patches in it that we need to think about? Or did somebody do a removal replacement? They did a lousy job and they have to replace it with new asphalt, so it's a fresher asphalt. Did we change the base asphalt in the area? When we switched over from the AC grades and the AR grades to the performance grades. So consider the presence of different, unusually soft or hard existing binders, or even asphalt rubber can affect the end use performance. And that's what we kind of want to focus on here. So why do binder properties matter? You can see this is a bunch of wrap chip that we've made for a project in the picture behind there. And the question is, when we're looking like this wrap chip, does the wrap gradation alone control long-term performance? So is the wrap gradation meaning it's like acting like a black rock, or is the parent gradation, the existing gravel and sand and aggregates that were used bound up in the asphalt? Will that fully soften to an extracted gradation? And this is probably the best way to do it. And it's a common thing that's being discussed throughout the country on hot recycling, is how much diffusion occurs, how much of the asphalt on the wrap softens and it goes to the parent gradation. Well, in hot recycling, you're going to be acting closer to the parent gradation. In cold recycle, it kind of depends. It depends on that binder. The same with the chip and slurries. It may be a black rock because that asphalt's so hard, or is it going to soften up to get closer to the extracted gradations? And this is before we really started paying attention. Years ago, when we first started using wrap on it, we had a job that, actually this was a cold recycle job, and you can see both sides of the road way different. And that's because there was some asphalt patches that were done with a solvent bearing patch that when we recycled it, it softened all the way to that parent gradation and caused a little rutting. Well, this was a very isolated area, just one patch, and we removed and replaced it and moved on, whereas the rest of the road held up really well. Well, now we focus on that. So let's talk about, for the rest of our presentation, just kind of keys to good wrap management. So when you're stockpiling, I'm looking just mostly at your facilities, keep clean and segregate if you have the room. So keep it free of deleterious materials, obviously trash. You don't want any of that in there. But also be careful. Try not to, when you're digging into wrap, get into that floor, get into the dirt that it's sitting on, because you're not going to probably have it on a paved surface. Make sure that loader operator doesn't dig down and grab a bunch of that dirt and mixing in non-coated aggregates into your really valuable wrap. The other is, if you can, segregate. And when I mean segregate, if you can't, and you have like a certain type of wrap, keep it all together. But if you know that all of a sudden you got maybe some asphalt rubber, or you got another, that is a product that maybe is behaving a little different, segregate it based on the asphalt type if you can. And also, if you look at the top picture, those are cold planing, from a mill. The bottom is removal, chunky removals. We like to segregate those materials, just pretty much those two piles, because we treat them a little bit different in the process that we're going to talk about. Now, a lot of times you can't do that, okay? And I understand it. You're just shoving all this wrap together, and we're going to talk about that in a second here. But the other is, every once in a while, test your wrap. Extract the binder and conduct an aggregate gradation. Recover the binder, and whether you like to base it on viscosity, penetration, or PG grading, every once in a while take that test and figure out what you got on there. Or develop your own test of determine binder softening. What I mean by that, and I'm not going to get into it, a lot of people say, hey, you know what? I crush the wrap down, I put it in a sample, or I put it in a Hamburg, and I know if I do a certain test and run it, I can see how much change in height occurs. There's a lot of different ones that you can do, but you can get to the point where you can do some really quick tests to go, you know what, this binder is going to soften up if it gets hot. It's going to have a lot of activity, use in it, or it's not going to soften. It's going to act like a black rock. And especially do this if you don't know the sources or new sources. So, and I'm not saying, hey, you got to put in a big, long, quality system like you do in a lot of the aggregates, but test it every once in a while. Make sure you're getting a consistency in your wrap. The reality, though, is a lot of this wrap, you can get away with a lot if you just homogenize, homogenize, homogenize. Consistency in your pile is the key. And what I mean by that is when you get new loads, and let's say you know what it is or not know, but blend it with your existing pile at different locations. Don't put it in one place that when you process it, you're going to get all that particular material. Put it all over your piles, especially on big piles. Mix it in at different levels of your pile. And then when you take your pile to process it, take it from different parts of the pile and blend when processing. It doesn't take but a couple of minutes to take a pile from one area, throw it, pile from another part of another load from another part of the pile, blend them together before processing. So you're homogenizing when you put the pile in place, you're homogenizing when you take it out, and finally when you're loading your trucks and you're making all your processes. And that should be done with any aggregate facility. Take your sample, take your loads from different parts of the pile and blend them in the truck. So again, homogenize, homogenize, homogenize. That makes a much more consistent wrap. And Steve talked about it, fractionate if you can. So when you make your products, blend them into different sizes so that when you add them together, you can get a much more consistent mix. You know, the hot mix guys started learning this years ago. If they just grab the wrap and put it in, they got not as much consistency. If they made it into two piles and then blended it back in. Fractionate if you can and have the room. Because when you do that, you can recombine it for better gradation. And this is a cold central plant. Steve talked about it. But here's where we use a 3-bin feeder. We actually had 2 sources of wrap. And at one point, we were adding a little bit of new aggregate to give a little bit more structure. We were afraid that that wrap was going to soften up a little too much. So we gave uncoated aggregate to absorb some of that asphalt and give a better overall performance. One of the keys when you're doing your wrap, the value is the asphalt on the rock. If you can keep it coated, you have so much less issues. So screen before crushing, and that's why we kind of keep our chunked asphalt away from our millings. Our millings, when they mill it, they actually don't tear the rock so much. They actually tear the asphalt, and it gives you really nice coated rock. So what we do is we screen. So this is one of our aggregate processing facilities. It goes into the feed hopper, and we screen off everything less than 3 inches. And so then we go in and we put them over 2 fractionating screens, depending on what we make. So we're trying to screen more than crush, just crush directly. And then only the oversized goes into crushing, and then it goes through the loop again. Because we don't want to open up those faces if we can, or change that parent gradation if we have to. And the reason is more coated rock, less activity and absorption. When I say activity, when you're using emulsions and you're doing them in chip seals or slurry seals or microsurfacing, if you have fresh crust faces, it may react with the emulsion differently than if the rock's been sitting for a while or it's not fresh face. And so that's why just screening it more, we have more coated rock. And you can see the rock here in this picture that it's got a little bit of asphalt all over it, and that's the value. And the other is absorption. I get a lot of times people saying, hey, you know what, we're cold in place recycling, we had absorptive aggregates. Well, we find we don't have to treat it so much when we cold recycle it, because the aggregate, the rock's mostly coated with asphalt already and prevents absorption. So let's not open crush faces if we don't have to. And this is one of the biggest challenges depending on space, but it's definitely not a challenge if you're making material, is limit stockpile heights. You know, time, temperature, and pressure causes these wrap piles to consolidate in the middle. And you can see these clumping. So when we make, we don't have this big issue with wrap chip because of kind of the openness of it. But when we make slurry material, we typically make it fresh to take to the site, because if we let it sit long enough, we get these little chunks developing in the center part of it. And so we just, if we have to, especially before we reload it, we may just run it over a screen. They break up pretty easy, or we just smash them out in the field. But if you get big wrap stockpile heights at your site, you know, you get 30, 40 feet. In the middle of it, you're going to have all these millings. They're going to just blend together. So you may have to break those up with a dozer or something to get them broken up. Same thing with cold central plant cold mix. If you make a mix that you're going to let for a couple of days, the higher you make it, the more you got that problem with it sticking in the middle. So try to limit your stockpile heights. And the other is when do you use water, when you don't use water. And this is a chip seal that was with a highly polymered emulsion. You can just see how much adhesion it has to it. So wrap has a dusty appearance. A lot of times in aggregate facilities, you want to get rid of that dust. Well, that dust is valuable in wrap. It's actually asphalt. Don't wash your wrap. You don't need to keep that material dusty. You may have to limit it for airborne concerns, but keep it, keep that asphalt there. But one thing we do is we wet, and Jason talked about that, breaking the surface tension, the water, and getting the ability for the emulsion to coat better. With emulsions, we wet our wrap before use for cold central plant recycling and chips and slurries. On the other hand, we try to keep it as dry as possible if we're going to use it in hot mix asphalt, or we're using hot rubber chip seals. We'll keep it dry. So consider when you're going to water your wrap and when you're going to keep it dry for these applications. A recap to good wrap management. 1, keep clean and segregate if you have the room. By far, one of the best controls. If not, we're going to manage it differently. Test it every once in a while. Simple test, whatever you need to do, just make sure you kind of know the difference if you're getting a binder that may give you a problem. But homogenize, keep your wrap. This is kind of one of the biggest keys, is always keep your pile blended. Blend in new materials at different parts. Keep it so it's consistent material. Fractionate if you can. Get it to the point where different sizes and recombine makes better products in the long run. Screen before crushing. Try to not crush as little as you can. Just size the rock from screening and then just crush what you have to get to. Limit stockpile heights. Make sure that you understand if you're going to keep it in a long time, temperature, and pressure are all going to cause consolidation in the middle. So if you can limit those heights or keep it stockpiled not as long, you're going to have less issues with that. And then use the water as needed. Emulsions, cold central plant recycling, chip seals, slurry seals. Moisten it, keep it moist, and if dry for HMA and for hot asphalt rubber. Hey, some of our best aggregates are on our roads, and it's getting harder and harder to open pits. Use your wrap. It's such a valuable commodity, and if you use it smartly, it's a money maker and it's good for the environment. But make sure you manage it wisely. Don't just think wrap is wrap is wrap. If you just use a little care, the quality can be so much better. With that, I thank you, and I think we're going to take some questions, but I'm going to turn it back over to Kevin.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.